Okay, what we want to do in this video is we want to solve an equation or solve a quadratic by completing the square. So very similar to the last video where you watched about taking something that was in standard form and turning it into vertex form, we're going to take that vertex form and we're going to take that standard form, we're going to turn it into vertex form, and then we're going to solve it. So the first thing we have to do is we have to make sure it equals 0. If it doesn't equal 0, then you got to do a little adding and subtracting to get it to equal 0. So make sure it equals 0. So I'm going to be nice, and I'm going to start with x squared plus 8x minus 20 equals 0. And then we're going to do what we were doing in the last video. We're going to use b and the c formula to make a new c. So remember, b is right here, stuck to the x, so b is 8. Our c formula said, hey, b divided by 2 squared. We're going to make a perfect squared c. So we're going to take that 8 and plug it in where the 2 or where the b is at. 8 divided by 2 is 4, and 4 squared is 16. So we've used b to make the new c. Now we're going to do the rewrite. So we're going to take this standard formula and we're going to say x squared plus 8x plus a blank minus the 20. All three parts of the original equation need to show up in your rewrite. So plus a blank, minus a blank, and it all still equals 0. In the blank, we're going to put that new c that we just made, that new square c that we just made. And then we're ready to start actually getting it solved. So we're going to shortcut factor the first 3 terms. And remember, the shortcut is x plus half of b squared. That's the shortcut factor. And then we're going to subtract the last 2 terms. So same thing as before. Shortcut factor the first 3 terms. Subtract the last 2 terms. Because we're taking that standard form and we're turning it into vertex form so that we can solve it. Because there's no way you can solve this problem with an x squared and an x in it. So we need to get it down to where we just have one x. So shortcut factoring says x, and our b is a positive, or half of our b is a positive 4, so plus 4 squared. And negative 20 minus 16 is negative 36, and that equals 0. So we've rewritten it into vertex form. So just like we did in the lesson on solving by undoing, the last thing you're going to do is solve the equation. So we want to isolate whatever's being squared. This whole thing is being squared, so we're going to isolate that by adding 36. So I have x plus 4 squared equals positive 36. Now I can take the square root of both sides, and remember, we're using the square root principle when we do this. So we're going to put a plus or minus in front of the square root of 36. The square root and the squared cancel each other out. So we have x plus 4 equals the plus or minus the square root of 36. 36 is a perfect square, and its square root is 6. So now we have x plus 4 equals plus or minus negative 6. So this is where we rewrite so that we can solve 2 little bitty one-step equations. X plus 4 minus 6 and x plus 4 equals a positive 6. This equals a negative 6, not just minus 6. And then we're going to subtract 4 from both sides because this 4 is being added, and we do the opposite. So the first time, negative 6 minus 4 is negative 10. And then the second time, positive 6 minus 4 is 2. So those are our 2 solutions. That's the place where this original quadratic crosses the x-axis at -10, +2, and we write that in set notation from least to greatest. Remember, don't use parentheses, use brackets. Even if the brackets come out looking crazy like that, I don't even know what those are really, but those are my brackets for this problem. If your brackets come out looking crazy, that's okay. They can look crazy, but they need to be brackets, not parentheses, because parentheses indicate something completely different. So let's do a couple more problems like this just to get a little more comfortable with it and to follow our steps. So x squared minus 6x minus 40 equals 0. So we make sure it equals 0. We're good there. We want to identify our b, which is -6, and we want to use our new c formula to make that new c. So we're going to say -6 divided by 2 squared, so that becomes -3 squared, and -3 squared is +9. Remember, use those parentheses. You got to have those parentheses or you're going to end up with a sign error. And then we do our rewrite. So, no y's anymore, we equal 0. X squared minus 6x plus a blank minus 40. That minus 40 comes from the original problem. Minus a blank, all still equals 0. We're going to substitute in that new c that we just made. And then we're going to use the shortcut to factor the first 3 terms, and then we're going to subtract the last 2 terms. So shortcut factoring says, hey, x in some parentheses squared, and the thing that goes in there is whatever your b was. B was negative, or half of your b. Half of b was -3, so we put a -3 in there. -40 minus 9 is -49. So we're at x minus 3 squared minus 49 equals 0. We want to isolate this. This is what we want to isolate. So we're going to do that by adding 49 to both sides. X minus 3 equals 49. So we're going to take the square root of both of those. Remember to do the square root principle. So square root cancels out squared. -3 equals plus or minus 7, because the square root of 49 is 7. And then we're going to write 2 small equations. X minus 3 equals -7. X minus 3 equals +7. So if you add 3, because you want to cancel this out and leave x by itself, add 3. -7 plus 3 is -4. And +7 plus 3 is +7 plus 3, 7, 8, 9, 10. 7, 8, 9, 10. So 10. Sorry. Had a moment there. Suddenly couldn't add anymore. So we add 3. So in set notation, we have a -4 and a +10. Remember to write your answer in set notation with brackets. Make sure that when you go to solve this, you will eventually get really good at it and you won't need to do this, but right now you need to write it as 2 separate equations and solve those 2 separate equations. Now, this is great if our function actually intersects the x-axis. If you think back to the first lesson we did on solving quadratics, we said there could be 0 answers. It's not really that there are 0 answers, it's more that there are 2 non-real solutions. We get 2 numbers, they're just imaginary numbers, and imaginary numbers are not something we graph. So they're just something we can actually solve for, and we can get complex numbers. So let's do that. Let's look at this one that doesn't actually intersect the x-axis anywhere, but you still get those non-real answers. So we identify our b as -10, and we make our new c by saying -10 divided by 2 squared is -5 squared, which is 25. And then we do our rewrite. X squared minus 10x plus a blank plus the 34 from the original equation minus a blank equals 0. So in our blanks we put a 25. And then we're going to take the first three terms, and we're going to shortcut factor them. X half of b is negative 5 squared. And then 34 minus 25 is a positive 9. So we all still equal 0. Now we're ready to use the square root principle and undoing to solve this. So we're going to subtract 9 from both sides. So we have x minus 5 squared equals negative 9. Then we're going to use the square root principle. But wait a minute. Look what happens. There's a negative. I'm going to go ahead and put that plus and minus there. There's a negative inside the square root. So when there's a negative inside, these guys aren't done yet. We're going to leave them in the house. When there's a negative inside a square root house, when there's a negative in that radical, it comes out as an I. And then we go back and we do the square root of that number. So the squared and the square root cancel each other out. And leave x minus 5 equals plus or minus. The square root of 9 is 3. There was an I we had already factored out, or it had already brought outside. So we'll bring that down. So now we're at x minus 5 equals plus or minus 3i. It's getting so long, but it's okay. Just take your time. So x minus 5 equals the negative 3i. X minus 5 equals the positive 3i. We add 5. So we end up with, remember, we've got an I here, so this needs to be written in A plus BI format. So 5 comes first, so 5 minus 3i. We add 5 over here, and you end up with x equals 5 plus 3i. So in set notation, this one's smaller because it's subtracting. So we say 5 minus 3i and 5 plus 3i. So you still get two answers, but if you were to graph it, you would see that this does not touch the x-axis anywhere. These are the imaginary numbers that are our x-intercept. So you could have one real number when you're solving quadratics, two real numbers, or two non-real numbers. So this is where we get the idea that there's 1, 2, or 0 answers. Two non-real numbers is that zero answer where we say, there's not actually a place where this quadratic intersects with the x-axis, but we can say that these would be the solutions when you solve it. And if you can't see the graph, because we didn't graph this, so we can't see the graph, we don't know, that's what this tells us. This tells us, hey, this graph doesn't actually intersect the x-axis anywhere at all.